Mute myself. Okay, so this is review of the vocabulary for systems of equations. So when you're solving, I have a couple of examples. So when you're solving and you get one solution, solution is actually the vocabulary word. Then there's no solution, there's infinite solutions, and we're gonna have this. So I'm gonna go ahead, and then when we're graphing systems, there's again one solution, no solution, and infinite. I'm going to graph them first to show you the examples. So if you're looking at two graphs, when we're looking at infinite solutions, what that means is, so if I had the equation y equals, let's do negative 2x plus 2. Remember the slope-intercept form, and I'm going to zoom in just a little bit. The slope-intercept form where the negative 2 would be our slope. This positive 2 would be our y-intercept, or where you start. So if you have infinite solutions, again, you start at a positive 2, that's our y-intercept, that's where it crosses the y-axis. Then you would go down 1, down 2, over 1, down 1, down 2, over 1, and continue that. If it's infinite solutions, it's going to be the same equation. So our second line, oops, let me do it in blue just so you can see the difference, would be y equals negative 2x plus 2 again. So again, start there, go down 1 over 2, or down 2 over 1, down 2 over 1. And so it would actually be the same exact line. So infinite solutions is the same line. Same line. No solutions is if we had something like y equals 5x plus 1. Oops, 5. That's almost too small. But so if I had, this one would start at positive 1. And then the slope would be 5. So 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. So there's our first line. Our second line could be y equals 5x minus 2. So we're going to start at negative 2. We're going to go up 1, 2, 3, 4, 5 over 1 and continue that pattern. So what it ends up being, use the edge of a Post-it. What it ends up being is two lines that would never cross. And that was a really bad example. But so let me draw just one more. So it would be two lines that never cross. So that would be no solution. And then one solution is just where you have them crossing at a single point. Let me use my Post-it again. So one solution is where they cross at a single point. So one solution, they cross once. No solution, they never cross. Infinite solution, they're the same line, so they touch everywhere. All right, now if we look at solving some, you're going to solve. So you're going to do 3 times x, which is 3x. 3 times negative 1 is negative 3. Bring down your equals. 2x plus 9. Notice these equations are not exactly the same. And one of the variables does not cancel. Sorry, hopefully that wasn't loud. So I'm going to circle my variables. That's the way I like to solve them. They're on opposite sides. So I need to do the opposite to one of them. So I'm going to subtract 2x, subtract 2x. 3x minus 2x is 1x, minus 3 equals 9. Circle the variable again. I'm trying to get the variable by itself. So what's the opposite of subtract 3? I would add 3, add 3. So 1x equals 9 plus 3, 9, 10, 11, 12. So 1x equals 12 or x equals 12. So if you get something that looks like x equals a number, that's one solution. Now, if we have no solution, sorry, hopefully that wasn't loud. Circle your variables. They're on opposite sides, so I need to do the opposite to one of them. So the opposite of a -7 would be a positive 7p. If I owe you 7 pineapples and I give you 7 pineapples, we're evened out. I could also add 7 on this side. A -7 plus 7 also cancels. So I'm left with 36. Bring down your equals. 35. Well, 36 does not equal 35, so it is no solution. Notice if you look at these two problems, the 7p's are exactly the same, or the -7p's. It's the number that's different. So if you look over at this, the number with x is the same. It's the other number that's different. So that's why it's no solution. Okay, infinite solutions. Last one. We're going to distribute that in. So it'd be 2x. 2 times 2 is 4 equals 2x plus 4. Notice these are exactly the same, kind of like these two were exactly the same. The variables are the same. The numbers at the end are the same. So what you're going to see when you solve this, let me use blue. We have 2x and 2x, again, opposite sides of the equation. So I'm going to subtract one of them, subtract one of them. 2x minus 2x cancels, 2x minus 2x cancels. So this case, we're left with 4 equals 4, which that is true. So that means the two equations are exactly the same, meaning it is infinite solutions. So that is how you would find your, that's how if you were solving. So when you're solving, that's what it looks like when you get one solution, x equals 12. No solution, when you're solving, it's a number does not equal another number. And then when it's infinite solutions, it's a number equals itself, gives you infinite solutions. And then again, the graphs, they cross in one spot, they never cross, or they're the same line, so they cross forever.